1 second. Now I think, is it okay now? The screen. So in fundamental particles we speak about electrons, protons and neutrons. Electrons charge E is equal to minus 1.602 into 10 to the power of minus 19 coulombs, and mass equal to how much? Mass equal to 9.11 into 10 to the power of minus 31 kg. And coming to the second one, that is proton. The protons, or the charge of proton is plus 1.602 into 10 to the power of minus 19 coulombs, and mass equal to what? 1.66 into 10 to the power of minus 27 kg. Third one is neutrons. So charge of neutron is how much? E is equal to 0, and mass of neutron is 1.67 into 10 to the power of minus 27 kg. Now, if you compare the mass of neutron to mass of proton, mass of neutron is greater than mass of proton. Okay, mass of neutron is greater than mass of proton. Yeah.
Neutron and proton weight is same.
No, neutron
charges,
but one is positive, the other is negative. And mass of electron here, mass of electron is 1 by 1837 divided into mass of the proton. Means if you break proton into that many parts, one part is the mass of electron. Okay, so that's so small is a electron. Okay, the first one comes to Thomson's model, J.J. Thomson's. Okay, first atomic model was proposed by Thomson's model, J.J. Thomson atomic model, or we also say plum pudding model. It's a model or plum pudding model or watermelon model. Okay, plum pudding model or watermelon model. Understood?
The mass of proton and neutron is similar.
Almost, but slightly mass of neutron is slightly greater than the mass of.
How do they measure the?
There is a method. No need to worry. This is done by chemical methods.
weighting scales are then
With the not the weighing scale, there is a different way to do it. Okay. The first one was done by R.A. Millikan. He found out that.
Indian scientist.
No, not Indian scientist. R.A. Millikan, not Murlikan. Millikan. R.A. Millikan. What is his name? Murugan. He's from, yeah, no. Yeah.
You will say that reflect rays on my head, and you will find his birds.
Yeah, I know. I have.
So shiny. It's very good.
No, he all the principals I met in. There was a meeting like 2019 last meeting of before panel. Like 1 week training program was there. PR training program.
So when you walk in sunrise, you can see two sun, one up and down.
Okay, anyways, this is a J.J. Thomson atomic model, that is plum pudding model. Okay, so according to him, he says that atom is like a watermelon, like the seeds on the watermelon are acting like a negative charge particle. He did not disclose that it is a electron. He told it is electrons, but he did not say this positive. This is positive stuff, he said. The flesh is positive charge. Okay, and he could not explain the stability and the balancing of the charges.
Basically, just predicted it.
He predicted. The next one came the Rutherford model. Are you there? Are you understanding? And the previous recordings I'm going to delete. Okay, and the new recording for February, all the February recordings I will upload on the. Okay, I will share that links with you. Okay.
So just make one drive and just keep uploading the thing into that drive.
But that is having a capacity 15 GB. In my Gmail. That is maximum. It is taking 1 month. After that I have to remove it. Old ones. You understand?
Videos. At least like store the videos in online so you can access it anytime.
How about uploading on YouTube?
I don't know that way.
I'll teach you.
Okay, no.
That is easy, so
then I will do that now. I'll do that. Okay, upload on the YouTube. Then I can share the link.
Yeah.
That will be easy for you. Okay, that I will do.
And then like then you can get views also.
I don't want views. I'm not aspirant of that.
You can make private videos.
Yeah, you can do that also.
Okay, that is better. We'll share it on YouTube. That is. You just show me how to do it.
Okay, it's quite easy.
Now, next one. How are you, Zion?
I'm fine, sir.
After a long time, man. You don't want to come to my home? Huh? Where do you-
I might come.
huh?
So he lives near this stadium.
Cricket stadium. Yeah.
So that's it.
Okay.
So he doesn't know where he lives exactly. So exactly you were saying your route, and that's why I understood he lives there.
Achha.
So he can come
Near to Yasmin building. Is it?
Yes, sir. Yes, sir.
Is it that you live in Yasmin
The
building?
Yasmin building is so popular. Mobile and Shekha or Al Hali.
Okay.
And cricket stadium is Yasmin building.
Yeah, because there is only one building over there.
No, so he's in villa. There's like a small villa area after that, yeah.
Backside.
That's
Yeah.
yes, sir. That's it.
That all industrial area.
Yeah,
Yes,
yeah.
sir.
One area is called Hazar Villa.
Okay.
There are
Okay.
1,000 villas.
Shall we go ahead with the Rutherford model? Quickly, we'll go with the Rutherford model, then gold foil experiment, then Bode's model. Okay? Clear, Zion? Anyways, this chapter I'm teaching from the beginning. Okay? Are you there?
So, but
Yes, sir.
you are like on 75%.
Yeah, no problem. I'll make it little faster. Don't worry. I'm not going to write the whole thing now. Okay, I'm just going to explain. That's it. Okay, the remaining.
doubts.
Okay, no problem. Now, okay, so the next one is Rutherford. First, I'll go with the Rutherford's gold foil experiment. Rutherford gold foil experiment, or we say gold foil experiment, or alpha scattering experiment. Alpha scattering experiment. Now, see here. Here, what he has taken is he has taken like this is the source of alpha particle. Source of alpha particle, that is said to be cesium. Caesium. Cesium. It's the source of alpha particle. Now there's a small hole here, and this is a lead box or lead chamber. Lead box or lead chamber. And now there is a small hole from where the alpha particles will come out. Okay. So there is a slit. Is there any slit? I think there is a slit
So
also.
there's a gap in the.
Yeah, small. There is a
Yeah.
slit like this.
There is a
And
gas in the.
Then after that, there is a gold foil.
Zinc skin.
Yeah, this is a gold foil whose thickness is gold foil
1,000 atoms.
10 to the power of minus 6 meters, 1 micrometer.
We can say 1,000 atoms also.
Yeah, 1,000 atom. Thickness means in one thickness means there will be around 1,000 atoms approximately. Okay, approximately 1,000 atoms. Now, and this is placed in zinc. This screen is zinc sulfide or zinc platinocyanide.
Yes, sir.
Okay, zinc sulfide or zinc platinocyanide, PTS. Cyanide, CN, PTSN, CN, sorry. Zinc sulfide or zinc platinocyanide. Okay, there's a screen. Now what happens is when these alpha particles will pass through this one, they hit the gold foil. And why this? First of all, I'll start from here. This is this is a source of alpha particle. Cesium is the source of alpha particle, and this cesium is placed in a lead chamber or lead box because lead is the stable element, and alpha particles will not react with the lead one. So, and also it will not allow the alpha particles to go out of that box. So most of the radioactive elements are placed in a lead box. Okay, and even the one more idea, that is the fuel rods, the used fuel rods of nuclear reactor also placed in the lead chambers.
Yeah.
They are preserved in that. They are not deposited in the land. Like they don't dig it and put it there in the
There
land.
was a case in US. So one girl ate some radioactive material, thinking it's some.
Chocolate or something.
Yeah. So her body started melting and decaying. So you know how they buried her in a lead coffin.
Yeah, that's right. Yeah. Because radioactive elements are very dangerous.
Yeah.
They're very dangerous. And the half-life of radioactive elements, there are some radioactive elements which will take thousands of years also. Half-life itself. It's decaying, but it's taking long time to decay. So that is why they are harmful. Now the second one, here it is state, because I don't want so many alpha particles to hit on the gold foil. And gold foil, why? Because gold is having a special property called malleability. So malleability means it can be rolled into long sheets, very long sheets. And also why? Because they won't, malleability means the substance will not get patches. Even if you are rolling like chapati, it won't get patches in between. So that is a special property of gold. And we are taking up to 10 to the power of minus 6. Why he has taken Rutherford like that? The reason is to make more and more thin. Okay. So for that reason. And also approximately the number of atoms in one thickness, in one layer, was around 1000 atoms. Okay. And also when these alpha particles hit the were made to hit the screen, gold foil, then what happened is they started scattering. They started scattering in different directions. Okay, like this, in different directions. Okay, and 1 in 10,000 there was head-on collision. So what happens whenever these alpha particles hit the screen, there will be a scintillation, shining or scintillation. Yeah, scintillation. That is fluorescence. This phenomenon is said to be fluorescence. Fluorescence means what? It's a delayed photoelectric effect. Delayed photoelectric effect is said to be fluorescence. Okay, that I will teach you in dual nature. I think already I taught this one. Okay, now so we say scintillations. The scintillations will take place. Okay, the next one, like what exactly is happening? See here, suppose this is the atom, this is a nucleus. The atoms, the alpha particles which go head-on collision, they don't penetrate actually. They are not penetrating. So there is a 1 in 10,000 undergoes head-on collision. Second one, the alpha particles which are very close. I am taking suppose 5 different rays example to make you understand. Now one which is very close, like scatters in this way. The one which is like this, it will go in 90 degrees collision. 90 degrees.
Perpendicular to the circumference of the.
Yeah, perpendicular to the, maybe 90 degrees with the incident.
So that alpha particles are neutral or negative?
Alpha particles are positive in charge.
So that the electrons are negative, so that will deflect it.
No. Nucleus is positive in charge. Positive repel. Then what are I will tell you the conclusions.
Positive.
What were his findings? And what were his conclusions from this experiment? These two I will discuss once I am done with this experiment. Okay. Conclusions and findings. What were his 3 findings and 3 conclusions? What he gave from this. Then after that I will discuss the what is fluorescence. Fluorescence means it is delayed photoelectric effect. What is photoelectric effect again in dual nature? When a ray of certain frequency incidents metal surface, then what will happen? Electrons are ejected outside. This completely depends upon the frequency. Keep that in the mind. H mean. It depends upon the frequency of the incident radiation. Frequency of 1000 times we have to discuss again. If I ask you, it should be only frequency of the incident radiation, does not depend upon the intensity. It does not depend upon the wavelength. First, it depends on the frequency of the incident radiation. Understood? So, if the frequency is sufficient, then only electron will be emitted. Electron will get ejected. Otherwise, it will not come. That is photoelectric effect. Delayed photoelectric effect means this is spontaneous phenomena. The ray will incident here and immediately the electron will get ejected. But in fluorescence phenomena, you have to expose this surface for some time, maybe for 5 minutes or 10 minutes or sometimes for 1 hour. Then they will get enough sufficient energy. Then the electron is emitted. Understood? So this is said to be the fluorescence phenomena. Understood all of you?
Yes, sir.
Yes, I am. Only for you
Yes,
I connected the speaker. If you don't say any yes or no, then it will be that will get upset. Is it clear?
sir.
Yeah, John, Joshua, and Ryan. Okay, I think he slept again. Sayam joined again. He slept. I have to open. Yes.
I'm not sleeping.
Started when we started 1:30.
It takes around 20 minutes for him to sleep. And then Sajid sir starts around 5 minutes for me to sleep.
Who?
Maths teacher.
Ah.
He does not know how to teach.
So he teaches maths by sitting down. That's how.
Right, it's good.
Yeah, this is how it is. So,
But in my life, I haven't taught by. I cannot take a class by
Sitting.
No,
Sir,
this is only because
sir,
of
he will speak math. He won't do math. He will only speak.
mathematics. Because I teach mathematics, so mathematics. The only way to learn mathematics or teach mathematics
By
by
doing.
Doing, yes, sir.
There is no other way.
He does not
So
know
he
how
will
to teach.
speak mathematics, sir. He won't do. He will just say what to do.
Even in PG also, when I was teaching masters or bachelors
Yeah.
also, I never. Even in university, you never have a chair also. First of all, there are long table. That's it. And no chair.
So, but then like he has so much knowledge, sir. He
Knowledge
knows
is there, but-
everything in maths.
Knowledge is there, but express.
Yes, sir.
Yeah, he does not know how to express his feelings.
Don't say feelings, huh?
So
So he says that.
Subject you say.
So he says feelings.
Okay. No. So now, so the scattering, see here, the more they get scattered, see here, the more it is away, more the, see, these are all the alpha particles. The more it is closer, the more is the deflection. As it is away,
They will slightly do.
the deflection will be less.
Yes, yeah.
The deflection will be less. Understood?
So the only last way goes straight or
It will go straight. It will go straight. Maybe. It will go straight. Okay.
So then if there's an electron, let's say right next to the
Maybe in the next part, next atom, you mean, or the
no,
electron?
sir, in the same atom, if the electron was there like right next to the fifth ray, only ray electron.
That is why he selected. No, because alpha particle is heavy in nature when compared to the electron. See, if you compare the alpha particle is the nucleus of helium atom, He2.4. Okay, this is heavier.
So that's
And already when I in the beginning when I was telling you about the electron, how much was the electron? It is 1/1837 the proton. Means what? It is like now electron is a small particle and alpha particle this much huge.
Yeah.
You understood?
Yes.
Electron
Yes,
is
sir.
very, very small now.
Yeah.
Okay, like think that a small hen next to standing to the elephant.
Yes.
Okay, yeah.
So this alpha particle will not get attracted
Yeah.
to that small one. So
Okay.
that is a thing. Is it clear?
Yeah.
So that is about the alpha particle scattering experiment. What were his findings and conclusions? We will discuss that. Then quickly we'll go to the Rutherford model and atom. Rutherford and Bohr's model. Okay. Is it clear, all of you?
Sir, I'm crystal clear. I know this.
Mr. Please, Zion, Joan,
Sir,
Joshua.
ask them to open the camera. Just say, I'll kick you out or.
Oh, okay. Don't use such words. Okay. Respectful.
Sir, they should respect you by opening the camera.
So okay, we cannot force.
If they want to study, then study, right?
Yeah. Is it clear, all of you? Mr. Zion, Joan.
Sleeping only.
Joan, Zion.
So
Sir, say them.
you just close the laptop.
Okay. So I'm going ahead with the findings. What are the findings? You be quiet, man. Earlier he also doesn't used to speak, huh?
He never speaks in
He was very quiet, huh? Now he is demanding, huh?
That's the reason I'm here. To study, or else I won't study. So entire grade 11, I never joined class. My entire percentage was 19. My attendance was 19.
Okay. Anyways, they gave the promotion, right? Because of
Sir,
CBSE.
Sir, I had to do some illegal stuff on promotion. Also, they were saying to 11th again.
What illegal you did?
Some stuff I
certificate.
Huh?
Certificate.
One medical certificate produced. That children do. Okay.
No, illegal.
It's illegal.
Not illegal.
Many do that. Okay. It's okay, but they are not in that area.
Sir, I had to make a medical certificate for 4 months.
What was the problem you were facing?
Sir, I made that I couldn't see I'm blind.
Huh?
I couldn't see I'm blind. My eyesight big problem. I had to get treated, I have to operate my eyes.
Out of the campus.
I'll write a mail to your principal. Wait.
So once I was playing football, suddenly the principal came behind me. I was like, oh shit, that shot was trash. And then he was like, what is trash, son? I was like, nothing, sir.
One second.
So that Rashid guy,
Mm-hmm.
he's in there in the school, sir.
It's
No,
Yeah,
he's
he's
not.
there, he's there.
Abdul Rashid.
So is Rashid.
Sir's Rashid.
Yeah,
Yeah. Now see here.
Smoking thing.
So we'll draw the graph. What was the finding was from the graph page. For model, Bohr model. Now
Sir, how much marks question will come from this part?
I will take that. Don't worry. Full before you leave, everything will be crystal clear. Don't worry. How many marks, everything.
Then we'll sit like a can of flour. We'll leave the back together. I will not take that.
But is having any enmity or what? Okay, now, so graph is like this. Okay, so the graph is in this way. So it is angle versus number of alpha particles. Number of alpha particles scattered. Okay, alpha particles scattered. Most of the time they are asking graphs. Okay, because physics goes with the graphs only. Comparison, everything, the path or the behavior can be explained only with the graphs.
Yeah.
So now this is 0 degrees. This is 90 degrees and this is 180 degrees.
So they were
Miss?
saying, right, a picture is worth 1,000 words.
Yeah.
So yeah, that
Yeah. Okay.
applies.
Okay. So like
Yeah, it's a picture.
Yeah, it's a
worth
picture.
1,000 words.
yeah.
Yeah.
Yeah. So now 180 degrees. See, there are the particles which are having head-on collision or maximum deflection. There are very few particles which are having very few, very less. Most of the particles. So what is the first finding? Most of them go straight. Okay, findings. What are the? Most of them go straight. Most of them. So most of them go straight. Okay, they don't deflect. Very few. So that is 1 in 10,000. 1 in 10,000. Some books they are saying 8,000 also. 1 in 10,000 particles. 1 in 10,000 particles undergo head-on collision. Okay, undergo head-on collision. 1 in 10,000 undergo head-on collision. Third one.
So over 10,000 or 1,000?
10,000. Sorry, 10,000. 10,000. 1 in 10,000 undergo head-on collision.
Or
And
1 in 8,000.
very few get deflected. So get deflected or scattered. Okay, deflected or scattered.
Most go through.
Yeah, most go through. Most of them they go through. So that is why there are 3 situations. When I was showing the video also, he was saying 3, no?
Yeah.
One is
Go
no
through,
deflection.
deflection or head on.
head-on collision and few deflections like that. Okay.
So
Yeah.
electrons charge is minus 1.662
Yeah.
into 10 raised to minus 19, and same is for proton but the positive. So if these alpha particles are being deflected by protons, why aren't they getting affected by electrons?
Not the protons. No, I'm coming to that one. This is only the findings. Conclusions are here.
Yes.
Okay. Conclusions. What he says is, according to the conclusions, he says that most of the atom is empty. He came to these 3 conclusions. Most of the atom is empty. Okay. Most of the atom is empty. Okay. What happened? Most. You want water?
Yes, I don't know.
One small one.
Just one.
So you drink it that big much.
We take no problem. Buffer put also to use. So most of the atom is empty, and the second one is alpha. He came to conclusion that alpha particles, anyways, he knows alpha particle is positive in charge. Okay, positive. Therefore, Nucleus is also positive. He came to, because of deflection only, he came to know that nucleus is positive in charge. Okay, nucleus is positive in charge. Okay, nucleus is positive in charge, and he also came to conclusion that most of the mass is at the center. Most of the mass is at the center. Is concentrated. Is concentrated at center. At the center, that is nucleus. Is that clear? Center called nucleus. These were his conclusions. Is it clear?
Yes, sir. Okay.
So you can take a picture, then we can go to the next one.
Yes, sir. Just doubt.
Is that ready? Okay.
Sir, electrons and protons have the same charge, but then it is minus and plus, right?
Charge, but mass are not the same.
But the mass of this thing is higher. Electron is higher.
The mass of the proton is very high. Minus 31. No?
Proton is 1.
No, forget about this. Look at its powers. It's 10,000 times lesser than the proton.
That means minus 31 is more zeros than minus 27.
That means minus 37 means how many?
27
0.0000 how many?
More times
Zero.
than this.
27 zeros.
Yes, sir.
Then 16911.
911, yes, sir.
Understood now? That many zeros.
Even a proton is very tiny.
That's what I'm saying.
It's so tiny.
Is it clear, all of you? Yes, sir. Zayan?
Don't even pick
Sir,
up
sir, in this experiment, the alpha particle strikes the nucleus. Yeah, 1 in 10,000 will hit the nucleus. It strikes and it will reflect back, bounces back. Is that clear? Is it clear, sir?
here.
Okay.
Gone only, sir, sleeping. So ate nice lunch after prayer and then slept nicely.
Okay then. Shall I go to the next one? The Rutherford atomic model, nuclear model.
They don't care, they don't care.
Reply.
They reply?
Yeah. Okay.
Yeah.
At least Sajid used to speak or something. This fellow he never used to. Huh? Not even chat box also. He will never reply. 10 times if I ask also, he will not reply. Now see. Now, so
So now you can ask me questions, I'll answer.
it's okay. So when we do numericals, then we'll come to know.
That will be interesting.
Yeah. So Rutherford atomic model. Atomic model or nuclear model. So according to Rutherford model, what he is saying, atom is here. So atom is spherical in shape. The entire mass of the atom is concentrated at the center part of the atom called nucleus. Nucleus consists of protons and neutrons, and electrons are revolving around the nucleus, like planets revolve around the sun. So therefore, this model is also known as atomic. This nuclear model.
So we have one question we'll ask after the class, or it's a question waste of time.
What happened?
It's a kind of from first term.
Yeah, tell me.
So if there was a battery and then a bulb, and then either side of the connection.
We'll draw this.
Then we can draw in a notebook. I can see. No, leave it. You can tell.
So there is a bulb like this over here. And
Okay.
there's a battery over here.
Okay.
Battery of X voltage. But then the connection between them, like it's a key also.
Okay. No problem.
And the connection between them is like, let's say 300,000 kilometers long.
Like 300,000 over here,
Each side.
300,000 over here. The
Ah,
wire is
understood.
extended.
So then the question was, how long will it take the bulb to shine?
And there is no resistance in the wire.
It's zero resistance. Imagine that the wire is zero resistance. No connecting.
Ah.
So then how long will the bulb take to? Is it 1 second? Is it 0.5 seconds? Is it 2 seconds? Or is it none of these? A, B, C, D, or
So long. It is so long.
It is 330,000.
That is okay. That is okay.
Very long.
Resistance is zero, whatever it is. The path, it will the path of the electron. So we have.
So you're on the right track. This
Yes,
people.
sir.
Yeah.
Is it 1, 0.5 or 2 or none of these? A, B, C, D.
So you're asking me the time. I equal to Q by T, T is equal to.
And what will
So T is equal to 1 by C, right? So T is equal to 1 by C.
How come?
So because time will.
Velocity is equal to C. Velocity is equal to displacement by time.
Yeah.
Yes, sir.
Displacement is equal to velocity by time.
Yes, sir.
Okay, if you are taking speed of light 3 into 10 to the power of 8
Exactly.
by
I don't know how it is t is equal to omni, but it's t is equal to omni.
okay, let us take t is equal to so what you will get, t is equal to c by x. No, sorry, t is equal to x by c.
Exactly, x by c.
X by c. X is how much? It will be some that divide by the 3 into 10 to the power of 8.
Yeah.
You will get the value.
Oh,
Then what is right?
Just do it. No? The
you
3
said it correct. Man. There
displacement
was an option
300,000
for
whatever you
C.
said,
Yes.
330,000 whatever, divide by speed of light. You will get the answer.
Yeah. And
Well,
what will
but
be
the-
the path of electrons?
What is that?
What will be the path of electrons? Will they go through the wire?
That is another question. Sir, the thing is, the bulb will stay on forever. Even if you close the switch.
Superconducting, that's what I'm saying. Even superconducting, what will happen is electrons, when resistance is 0, electrons will continuously move. No external force required.
If that is when the switch is closed.
Switch is closed.
Yeah, but
So
then
when
when
it
switch
is-
is open,
It
will always
still stay
slide.
on.
That means the filament is not having any resistance.
No, sir. It's a bulb, normal bulb.
Bulb means it has a filament. It has resistance.
Yes, sir.
When it will go.
So,
But then-
then this bulb will glow even if you open the switch. That is how it is. Sir.
from the air, electrons always jump, right?
No,
There's
so
a
what
magnetic field.
No, so what happens is from this open switch, there are some positive leakage. Like they can't get
Leakage takes place. Leakage.
So what happens is like here there's like a small like negative charge over because the battery is over here.
What happened? I will tell you.
So this will
See,
attract.
in general, suppose if there was resistance here, what would have happened? Then this resistance is
We are
negative.
on tiny detour.
But now,
You guys can
now
sleep.
what happens if now there is no resistance at all?
Yes, sir.
When compared to this one, this is having little resistance.
Yes, sir. Yes, sir. Yes, sir.
So that is the reason it is flowing.
Yes,
It's like vacuum creation.
That
It's like you are creating a vacuum over there.
And also, I want to say one more important thing. That the distance from this one to this one is 1 meter.
Oh.
But then the distance over here is like x length.
Yeah, you told me 330
Yeah,
something.
yeah.
Okay, clear now? Got it? It's behind me now. Okay. Anyways, Rutherford atomic model. Atom is spherical in shape. The entire mass of the atom is concentrated at the center part of the atom called nucleus. Nucleus is positive in charge. Nucleus consists of protons and neutrons, and electrons are revolving around the nucleus like planets revolve around the sun. So therefore, this model is also known as this model is also known as
Rutherford atomic model.
planetary model.
Planetary, okay. Major sun, planets, electron. What? Yeah.
Okay, now-
Landed some aircraft on the sun.
Now, we'll send him to Ukraine, man. Now, this guy. Huh? Now,
They will transport me to UAE.
okay, draw back. So next one, the first one, he says that hydrogen spectrum. Okay. The first one, he spoke about the spiral orbits. He says that electrons are moving in a spiral orbit, and finally it falls into the nucleus, and nucleus will collapse. But it is
That's false theory.
but it is
That's wrong.
it is losing its energy continuously, and finally electrons are revolving in spiral orbits, and they are losing the energy continuously, and finally when it becomes zero, it falls into the nucleus,
Okay.
and nucleus will collapse. But it is found in the nature that it is stable. Here, the second one is what about the hydrogen spectrum, H spectrum, hydrogen atom spectrum. What is the hydrogen atom spectrum? He says that what he's saying in hydrogen spectrum,
Yeah.
in hydrogen spectrum, it should be a line spectrum, but he said it is a continuous spectrum.
Yeah.
There he made a mistake. It is a continuous because he was not having that much idea of spectrum. He said that it is a continuous spectrum, but it is practically speaking, it is not a continuous spectrum. It is a line spectrum. It is a discontinuous spectrum, which is a line spectrum. Is it clear, all of you? Yes, sir. Is it clear?
Sir, what if this was true? The spiral thing. Sir,
Atoms will collapse.
Won't
So
exist.
if atoms will collapse, won't they make some other thing as a result?
Collapse means what?
They'll become a bomb.
Like burst.
They'll
So
bomb.
like they do produce quarks or something like that. Right?
Yeah, that will happen only
So
when
what if-
quarks okay, I got it. Quark particles will happen when if you have to for that you have to study about the Einstein's special theory of relativity. That I will explain, no problem. Don't worry. How the quark particles exist? What is the classification of quark particle? Physics is not a small thing. It's a very huge to understand. Okay, that is a different field called high energy physics laboratory. That high energy physics. To understand the quark particles, again, it's not even a part of nuclear physics. Not even a part of nuclear physics. Again, there is high energy physics and nuclear physics. There is one more classification of nuclear physics. In that it is there. So, how the quark particle exists? How do we get the quark particles? That is a big story.